So I talked about spider silk, I talked about materials, and so what I'd like to move now to is why study these complex fluids, okay? So, as I said, the first thing that you tend to think of when faced with asking people about foam, you say, I study foam, and they go, well, what's that? Bubbles and, air bubbles and water. Oh, you mean foam? Yes, I mean foam. Why would you do this? And technologically, it's pretty obvious. And this is part of a very broad area of what we call soft condensed matter, because the materials are squishy, which is almost all things that are complex fluids. These are granular materials, powders, pills in pharmacies having to travel from where they're made to where they get in the jars, grains in silos, emulsions, paste, slurries, paint on your wall. Things that are particularly foams get used in oil recovery. They're kind of to get the last bit of oil out of the rock. Firefighting, so I have a picture here with firefighting. Actually, ore separation. Foams are used to separate the useful minerals that you want in the ore. Food products, so Guinness beer. It's a little bad picture because the foam is white and the background's white, but turns out one of the main centers of foam research is in Dublin, Ireland. That's actually true. That's not a joke. And so I feel compelled to have a picture of Guinness in every talk I give. Beauty products, anything that foams up, mousse, shampoo, toothpaste, shaving cream. In fact, one of the standards in scientific research on foam is Gillette Foamy. I don't know if I'm allowed to say the brand name, but it shows up in all the papers, that people publish on it. It actually has very good properties and is very reproducible and stable. And of course, I've noticed we haven't had one recently, but during Welcome Week, UCI always had a foam party for a long period of time while I was here. These became popular, and this is an actual machine you can buy to spray the foam. A foam party is literally you get sprayed in foam at the party. And so you can see my research is very important. So the technological applications are pretty obvious, and you could just think of all the other products I mentioned in terms of granular material and such. But you might ask, well, what's kind of the fundamental question then? And it comes down to, what are the states of matter? That's how I like to talk about it, right? You've all learned, someone tell me, what are the states of matter? Solid, gas, liquid, and then you'll read, and plasma, that gets stuck in. Of course, what's interesting is nobody ever mentions liquid crystals. How many of you have an LCD TV? It's my little pet peeve because I studied liquid crystals for a while, and they don't make it in as a state of matter, and they are a separate phase, but they're never in the introductory textbooks. So, and then if you ask people, what are solids and fluids, or liquids and gas, you have transitions between them, and you want to understand those transitions. And a lot of it on the macroscopic level, when you just look at it, comes to whether it flows or not. So I picked pictures of different things that flow, and various terms up here, solid, fluid, plastic, glass. So here's some glass. You often hear glass talked of as being this material that's just a fluid with a very, very high viscosity, and so it flows so slowly you don't know it. But maybe there's an actual transition there. Maybe it really is solid since it looks solid. But I put in the middle here because all of us are from Southern California, and I think we understand one of the most important transitions in what we call, in soft condensed matter, jammed to unjammed, and that is traffic. Okay? We have all been in traffic jams. Okay? And we can understand that when the density of the cars gets too high, you don't flow anymore. That's rush hour. You go 0, maybe you go 10, maybe you're a glassy state and you're flowing very slowly. Okay? If there's a low density, you flow. You get along and you drive, because we all drive at 65, right, the speed limit, and you're just going there at 65. Okay? But I think we've all had this experience, and this is a very important physics issue here. We've had the experience of what we call fluctuations. That's the technical term. You've been on the freeway, suddenly the cars start jamming up. You're getting all pissed, you think maybe there's an accident, what's going on? Suddenly you're driving again. No sign of an accident, you don't know why. Suddenly, you're stopped again. Okay? And if it's not those police who drive in front of everybody slowing us down, it's because you're near the jamming transition. Okay? And in phase transitions, as we call it in physics, as you go from one state to another, okay, at that transition point, fluctuations become very important. And fluctuations can occur on very, very large length scales, and the length scale can scale with various other properties of the system. So as the density starts getting higher and you're almost in a traffic jam, you experience this obnoxious behavior of jamming, unjamming, jamming, unjamming. Okay? And these fluctuations can have characteristic features that tell us about the transition and let us know what we're looking at. I'm not going to show you much more on fluctuations in this, but this is one of the things we look at when we ask about whether foam is a solid or fluid. Okay?